Okay, so we're going to be doing adding and subtracting fractions in this video. For a lot of people, this may be the first time that you're taking notes from one of our math videos, so I want to remind you a few things. As we go through this, make sure that you take notes, not only copying down the examples and the information that's written down, but also paying attention to what's being said and writing down the important information from that as well. Feel free to pause or rewind this video as you need in order to get down good notes that will help you and will make sense to you in the future. If something isn't making sense and by rewatching it still doesn't clear it up, you should write down those questions along the side of your notes so that when you come to class next time, you can ask either the teacher or a classmate and get some clarification. Lastly, at the end, we're going to ask you to summarize what it is that you've learned by watching these notes, or maybe what it is that are the important parts of the notes, so that way we make sure that you're processing what we're talking about. Let's begin. In order to begin talking about adding and subtracting, we actually have to start by reviewing the basics. First of all, how to change between mixed numbers and improper fractions. Don't mind my little scratch outs there. We prefer improper fractions, but mixed numbers are another common way of expressing values larger than 1, so we need to know how to go back and forth. Let's start with this example. If I have the improper fraction 73 over 4, by the way, how do we know it's improper? Because the numerator is larger than the denominator. Remember that this fraction bar is another way of showing division, so I can divide 73 divided by 4. Well, 4 will go into 7 once, with a remainder of 3, and 4 will go into 33 8 times with a remainder of 1. The quotient here, the 18, the whole part of the quotient, is the whole number part of our equivalent mixed number. The remainder is placed in the numerator over the denominator, which is the same denominator we had before. So 73 over 4 is the same thing as 18 and 1/4. Now what if I need to go the other way? If I have the mixed number 2 and 4/7, how do I change that into an improper fraction? Well, remember that this tells us the size of the pieces. If I have 2 wholes and I was breaking each one into 7 pieces each, then 2 times 7 tells me that would give me 14 pieces from the wholes. Then I would have to add the 4 pieces I already have, and that adds up to a total of 18 pieces. 18 pieces that are each 1/7 in size. For some reason, people make a mistake when we suddenly now have a negative mixed number. This negative sign applies to the entire mixed number, not just to the whole number. You're going to follow the exact same procedure, but then at the end, bring the negative sign over into your final answer improper fraction form. I would say 5 wholes times 8 pieces each gives me 40 pieces from all of those wholes, plus the 3 pieces I already have gives me 43 pieces. So I have 43 pieces that are each 1/8 in size, and they all happen to be negative. So it's negative 43 over 8. Now let's look at comparing and ordering fractions. In order to put fractions in order to compare them and tell which ones are bigger or smaller than the others, we need to get common denominators. We need to have everything on an equal playing field so that we can pretty easily compare and figure out which ones are larger and which ones are smaller. And pay attention to negatives. Just like if I'm comparing integers, right, all negatives are going to be smaller than all positives. And then from there we can start to make distinctions. The same is true about thinking about where these numbers go on number lines. Further to the left means it's smaller, further to the right means it's larger. So let's take a look at a couple of examples here. 4/7 compared with 3/4. We want to fill in the inequality symbol here, but I need common denominators. One easy way of finding common denominators is multiplying our 2 known denominators together. 7 times 4 is 28. But if I multiply the 7 times the 4, I also need to multiply the 4 times the 4. Remember, that's because I'm just multiplying this fraction times the number 1, 4 over 4. And multiplying times 1 doesn't change its value. It just changes the way that it looks. So 4 times 4 gives me 16 28ths, which is equivalent, but I've changed the way that it looks. Here, I get 28 because I did 4 times 7, and I need to show that I'm also multiplying the numerator by that same 7. And 3 times 7 is 21. So which of these is larger? 3/4 is larger than 4/7. 21/28 is larger than 16/28. When I come over here, I need to pay attention to my negatives in all of this work that I'm doing. For 7 and 5, 35, the product, is the common denominator that we can use. So since I do 7 times 5, I would also need to do -4 times 5, and that would give me -20. Here, 5 times 7 gives me 35, so 3 times 7 gives me -21. So which of these is bigger, -20/35 or -21/35? If the 35th part is confusing you, the answer is the same if I'm just comparing -20 to -21. Which of those is larger? Which of those is farther to the right? And since these are both on the negative sign of 0, which one of these is closer to 0? Oh, that's -20. So -20/35, or in other words, -4/7, is greater than -3/5. Now let's talk about simplifying. We want you to simplify your fraction until the numerator and denominator are relatively prime. That term means that the only factor that they have in common is 1. All numbers have 1 as a factor, but reducing or dividing by 1 doesn't change the value. So we kind of tend to ignore it when we think about reducing fractions. It is there, but it's not going to make an impact. You want to keep simplifying until your numerator and denominator no longer have any other common factors besides that 1. So for example, if I have 48/60, just like we were showing above, we want to show how we're reducing these fractions and keeping them equivalent down here as we simplify. There are lots of things, lots of factors that 48 and 60 have in common. Just pick one and dive right in. If you don't like to show a lot of work, then you want to try to find larger common factors. If you don't really like spending a long time looking for common factors, then as soon as you find one, reduce by that. I notice they're both even, so I'm going to reduce both by 2, because again, that's just a form of the number 1. I can divide by 1, and that's not changing the value. So that would give me 24/30. Maybe now you can recognize, oh, these are both divisible by 3, and that gives me 8/10. I see that they still have a factor in common. In this case, again, they're both even, so I can divide them both by 2, and I get 4/5. 4 and 5 are relatively prime. The only factor they have in common is a 1. So this means my answer is completely simplified. Now, when it comes to completely simplified, you need to understand something. If it's not simplified, then it's not right. You must completely simplify your fractional answers. Otherwise, everyone in the room could have a different answer, and we would spend forever checking the equivalency of all of these fractions. In order to make our lives simpler, we are going to make our fractions simpler all the way. And if you don't, then you will not get credit for that answer. So please make sure to check that it is completely simplified. That being said, completely simplified does not mean mixed numbers. A lot of times in elementary school, our teachers tell us we have to change improper fractions to mixed numbers. That's not true here. The more algebraic our work becomes, the more handy improper fractions are going to be. So we're just going to start doing that now. We prefer improper fractions instead of mixed numbers. There are a couple of exceptions. Like always, all rules have some exceptions. If you are trying to work with coordinate pairs, it's not going to make sense to try to find where -11/4, comma 14/3 is located. That's going to make a lot more sense if we express those as mixed numbers. The same for answers to word problems. We don't want to talk about having to buy 18/5 cans of paint. That doesn't really make sense. So with word problems, you're going to want to change to mixed numbers, because that's what makes sense in that context. But in general, if you're just doing math, we prefer improper fractions. Plus, that keeps you from making a mistake at the very end, converting to a mixed number and making a mistake in that last step and getting your answer wrong. So it's time for our first do now, which is actually a pair of do nows. When we have do now problems, you're going to pause the video so that you can see and read the questions, work them out on your own on your paper, and then start the video to see how we work it out and check your answers. So pause it and do these problems now. Let's see how you did. We want to put these fractions in order from greatest to least. Make sure that you're paying attention to that, greatest to least. The biggest numbers in here are going to be our positives. I don't need to worry about the negatives for now. Let me just worry about the positives. Well, for 4/9 and 2/6, let's change those to common denominators. The least common denominator I can use here would be 18s. So this times 2 means I have to do 4 times 2, and I get 8 18ths. This times 3 means I also have to do 2 times 3, which gives me 6 18ths. So the 4/9 is larger and is going to go first, followed by the 2/6. Now I can compare my negatives. I know that all of my negatives are smaller than my positives. That's why I didn't have to worry about having a common denominator for all 5 at the same time. But since these are all going to be on the left side of 0, I need to figure out which of those is going to be further to the right, which one's going to be further to the left. And so between thirds, sixths, and twelfths, twelfths is my common denominator. Negative 2/3 means I would have to multiply the denominator times 12, so negative 2 times, sorry, the denominator times 4 to get 12, so the numerator times 4 gives me negative 8. Negative 5/6 to convert to twelfths means I have to multiply times 2, so in my numerator I get negative 10, and I can leave negative 17 twelfths as it is. Hopefully you might have already recognized that negative 17 twelfths is going to be furthest to the left, in other words, the least, because it's an improper fraction. It's more than 1. So it's going to be further to the left than these other negative fractions that are between 0 and 1. But when I compare those two, I see negative 2/3 is the greater of the two fractions. Since they're both negative, right, this one is going to be closer to 0, so it is greater than this one. So negative 2/3, and then negative 5/6, and then negative 17 twelfths. There are fractions in order from greatest to least. As I simplify 126 over 210, I start to look for common factors. I notice that these are both even. I'm going to start to divide by 2. That gives me 63 over 105. Now, if you don't know the shortcut, if I can add the digits of a number together and the total I get is a multiple of 3, then the original number is a multiple of 3. And that's true in both of these cases. 6 plus 3 is 9. 9 is divisible by 3, so is 63. And 1 plus 0 plus 5 is 6. That's divisible by 3, so is 105. So I'm going to divide these both by 3. That gives me 21 over 35. Now, some people might start to see, oh, well, they're odd numbers. I can't divide by 2. This one's not divisible by 3. I can't divide by 3, and then give up. But there are many more factors out there. In this case, these are both divisible by 7, right? So you got to keep checking to make sure things are relatively prime. And when I divide them both by 7, I get 3/5. 3 and 5 are relatively prime to each other. So that's our final simplified answer. All right, it's time to get back to the topic at hand, which is actually adding and subtracting fractions. So remember, when that's what you want to do, you have to have common denominators, whether you're adding or subtracting, either way. There are a few ways to find common denominators. One common method I mentioned earlier is by multiplying the two denominators together. If you always do it that way, then you're going to have to spend a little more time at the end seeing if you can simplify. Because when we just take and multiply our two denominators together, we're more likely to have to do more simplifying at the end. So here, if I do 6 times 8 and say that I want to use 48, and I multiply those both by 8, and that gives me 40 over 48, and I multiply these both by 6 so that I get 18 over 48, and then I make sure to add. Be careful that you are performing the correct operation after you change your fractions to common denominators. That adds up, and that gives us 58 out of 48. Oh, but wait a minute, those are both even. I need to reduce both of those by 2, and that gives me 29 over 24. Those are relatively prime. I can't simplify that anymore, and I don't need to change it to a mixed number. However, if I had started looking for that least common denominator, between 6 and 8, that least common multiple, I wouldn't have to do this reducing at the end, because the least common multiple for 6 and for 8 is actually 24. 6 times 4 gives us 24, so 5 times 4 on top gives us 20 as the numerator. 8 times 3 gives us 24, so 3 times 3 means we have 9. 20 plus 9 gives us 29/24 as our fraction. So, in this case, it's really fast to find the common denominator, but we have some more work to do at the end. In this case, we might have to take a little more time in the beginning to search and find the least common denominator, but it saves us work at the end. So you choose whatever's going to help you and be best for you. But notice, after you find common denominators, the answer keeps the common denominator. Don't do all that work to get a common denominator and then mess it up and get rid of it. So your answer keeps the common denominator. Unless, of course, you have to reduce, right? When you're simplifying, everything might simplify out. But my point is, as you're adding and subtracting, you are only adding and subtracting the numerators. If it's mixed numbers, then yes, the whole numbers as well. But you are not adding or subtracting the common denominators. In fact, that really doesn't make sense. If you're subtracting things with common denominators, then you would get a denominator of 0, and that's definitely wrong. Let's talk about using improper fractions versus using mixed numbers for when you have these addition and subtraction problems. There are pros and cons in both cases. The reason you might want to change everything to improper fractions is people often forget to work with the whole numbers after they spend all their time and concentration getting common denominators and making equivalent fractional parts. Then they might forget to work with the whole numbers. Also, sometimes people have a hard time when they have to borrow as they're subtracting. If one fraction doesn't have enough in it to subtract the other fraction, then you have to do some borrowing, which can sometimes be a little bit tricky. However, using mixed numbers is also nice because that keeps our fractions, especially our numerators, from getting too big if we keep the whole number part separate from the fractional part. So I want to show you a couple of examples as to when it might be good to do one versus the other. So if I have 8 1/6 minus 5 1/3 here, right? This is one of those cases where once I get my common denominator and I convert them, so 6 is going to be the best common denominator to use. This stays 8 1/6, but here I have 5 2/6. Wait a minute, 1/6 minus 2/6. I can't do 1/6 minus 2/6. So normally I would have to borrow, but that can be complicated for some people. So instead, I'm going to change everything to improper fractions. 8 times 6 is 48, plus 1 is 49. 5 times 6 is 30, plus 2 is 32. And when I subtract those numerators, notice it's pretty easy. 49 minus 32 gives me 17/6, which is my final answer. That can't be simplified. I don't need to change it back into mixed numbers, since this wasn't a word problem. But these numbers are also kind of small. Notice nothing got too crazy large. That isn't always going to be the case. Take a look over here. 14 1/2 plus 8 5/8. So again, common denominators first. 8 looks like it's going to be the best bet. So times 4 gives me 14 4/8 plus 8 5/8. Now, if I were to change these into improper fractions, 14 times 8 plus extra, that's going to get to be pretty big. It's going to get to be a triple-digit number. You might not want to deal with that, right? Also, since we're adding here, usually people do a little bit of a better job of carrying things over instead of borrowing. So when I add my two fractional parts together, I get 9/8. When I add my whole number parts together, I get 22 9/8. But wait a minute, I can't leave an improper fraction as part of a mixed number. Improper fractions are great on their own, not as part of a mixed number. That's not allowed. So I've got to take the extra whole out of here, take 8/8 away to give myself an extra whole, leaving me 1/8 left over. So again, just an example of a time where using mixed numbers might be better. I want to remind you, integer rules still apply. That's right, you're in Advanced Math 7, where you might have to work with fractions and integer rules all at the same time. And if you haven't noticed, let me give you a little tip. These three fractions all mean the same thing, but you should always put your negative sign in the numerator. And if you look back through this video, you'll see that I do that. Because as you're adding and subtracting fractions, you're really mainly focusing on those numerators. So you want that negative sign up there in the numerator, so that if you're adding some numbers together, oh wait, I've got some positives and negatives, let me apply the correct rules. If your negative is down here in the denominator, this fraction on its own does still equal these other two fractions, but chances are you're going to forget about that negative sign there. By the way, if you can't tell, right, this is the opposite of 2 divided by 3. That would give us a negative. This is a negative 2 divided by a positive 3. That would give us a negative. A positive 2 divided by a negative 3. That would give us a negative, right? No matter what the numbers are, the negative sign can go in any of these three places and still give you a negative fraction. But this is the way you should always do it. Focus on keeping your negatives with the numerator at all times. So let's take a look here. If I have this example to work out, and first of all, you might want to change everything to common denominators. Looks like twelfths is the best way to go. So I can keep my 11 twelfths. Times 2 gives me 10 twelfths. And times 4 gives me 8 twelfths. You might also want to change all of your subtractions to plus negative. So 11 twelfths plus negative 10 twelfths. Then plus negative 8 twelfths. So 12s is my common denominator. 11 plus negative 10 plus negative 8. Well, 11 plus negative 10 is 1. 1 plus negative 8 gives me negative 7 twelfths. I check. That can't be simplified, so there is my answer. Last do now problems. Also to point out, if you haven't seen this and been paying attention so far, notice I've been indicating the numbers with some kind of sign or symbol around the numbers. That just helps them stand out. You should do that also. So here, do now number 3, that's double underlined, a star around number 4, a circle around number 5. Pause the video now, work out these problems. Let's see how you did. So, 2 and 5/8 plus 3 and 7/12. If I were to just multiply the denominators, that would give me, I think, 108. Nope, that would give me 96. Still a very large denominator. I don't want to do that. So I pay attention. Oh, wait, 20/4. That's the least common denominator that I can use. So times 3 and times 3 means I have 2 and 15 20/4. Times 2 and times 2 here means that I have 3 and 14 20/4. When I add those together, I get 5 and 29 20/4. But I cannot leave an improper fraction as part of a mixed number. So take 24 20/4 to give us another whole. We have 6 wholes, leaving us with 5 20/4. That can't be reduced, so there's my final answer. 1 and 5/9 minus 5/6. Common denominators first. Looks like the smallest one would be 18. So 1 and 10/18 minus 15/18. But wait a minute, I can't take 15 away from 10. So this might be a good time to change this to an improper fraction. 1 times 18 is 18, plus 10, 28/18. Minus 15/18, leaving us with 13/18. That's a 3. And can't be simplified. Those are relatively prime, so there's my final answer. Last but not least, 1/8 minus 19/40. So common denominator says, let's get common denominators. Luckily, I can change this to 40 pretty easily, and I can leave my second fraction as 19/40. Notice not everything has to change to get common denominators. Oh, but 5 minus 19, normally, right, we would say we can't do this, we need to borrow, we need to do something, except there is no whole number to borrow. So this is where I need to remember my integer rules, right? I'm going to change that into plus negative. 5 plus negative 19 gives me negative 14/40. That can be simplified by dividing them by 2, which gives me negative 7/20. Those are now relatively prime, and I have my final answer. So this is the end of the video. You're going to stop and take a few minutes to summarize what it is that we've talked about and the main points that you need to remember here at the end of your notes. Please practice writing complete sentences. I don't mean complete sentences in the sense of what I have learned from these notes is ... No, you don't have to do that. Complete sentences as in don't use shorthand, abbreviations, text messaging kind of writing. Write complete grammatical sentences that have a subject and a verb and stuff happening and a period at the end, and they don't go on forever and ever. Thank you very much, and I'll see you in class.